Today we are going to be talking about micro-frontends with Blazor. So thanks everyone for joining. I hope this will be an informative session, and you'll learn a bit more about both micro-frontend architecture and about how it can be utilized in Blazor. I'm Shaun Walker. I'm the founder of Devessence, which is a boutique consulting company that focuses on Microsoft-based technologies. I'm a Microsoft MVP. I've been an MVP for I think 16 years now. I was also the creator of a couple of popular open source projects, one of which was called .NetNuke, sometimes referred to as DNN, and more recently an open source project called Oqtane. I've also been a volunteer with the .NET Foundation for a long time, since it was created in 2014, and I'm the chair of the project committee currently. So let's talk about micro-frontends, sometimes abbreviated as MFE. And so I found this definition of what micro-frontends are online. So an architecture that provides a way to build large, complex web applications by breaking them down into smaller, more manageable and independent modules, which enables faster development, deployment, and scalability while still maintaining a cohesive user experience. So it's a lot of words. But I'm going to dig into this a little bit further so that it's more understandable about what this actually means. But first, let's take a little bit of a step back into history to understand like where this originated from, where did this term come from, and why has it become sort of popular over time. So if we go back to 2011, that's when the initial concept of microservices was introduced. And of course, everyone's pretty aware of what microservices are now. Microservices were largely focused on solving a problem for the back end of applications and breaking those down into smaller parts so that they could be deployed and scaled independently. In 2016, ThoughtWorks, which is obviously a very well-known software development company, introduced the term micro-frontends, and this was part of one of their annual reports when they were talking about new technologies that were emerging. In 2017, a JavaScript-based solution came along, and it was called Single SPA. And the idea behind Single SPA is it tried to solve some of the initial problems that were identified around micro-frontends and around basically breaking the front end of an application down into smaller parts so that they would work effectively. In 2019, Martin Fowler, who is one of the founders of ThoughtWorks, wrote a fairly definitive article on micro-frontends, which kind of brought it more into the mainstream. And then in 2020, a new sort of technique was introduced in the JavaScript community called module federation. And module federation is quite a popular solution now for building micro front-end solutions, especially with JavaScript. And now we're like 2025, so 5 years later into this, and obviously this concept has really demonstrated that it provides value in a lot of different contexts. And I include like a caveat here at the bottom. So although the term micro front end was credited to the JavaScript community, the concept of modular UI has existed for much longer, and it's been used in many different technology stacks over time. So we just didn't call it micro front ends. We called it, modular architecture, or we called it dynamic applications, or we called it many, many different things other than micro front end. But it's really the same concept. All right, moving along. So when we think about applications and the ways that they are architected, I broke them down into sort of 4 different common patterns. So on the left-hand side here, we have the very common monolithic pattern, right? The pattern where you build an application and both the front end and the back end code is combined in the same application. And of course, there's a lot of applications that are still being developed this way. And this was a very popular way of building like legacy applications. The client-server approach, sometimes referred to as the single-page application or SPA approach, broke apart the front end from the back end into discrete applications that could interact with one another using, either, HTTP endpoints or even perhaps database or whatever, what have you, maybe even messaging. But the idea there was the application that was sort of one cohesive unit in a monolith was broken down into both a front end and a back end. And that's also been a very popular architectural approach over time. Microservices, which we just talked about, which were introduced in 2011, basically took that notion of the back end and broke it down into independent services. And those services would be developed independently from one another, maintained independently, and deployed independently. And so that provided a lot of benefits around scalability. And it also created a lot of complexity around sort of modern applications as well. And then moving forward, of course, then we had the micro-front-end concept, which emerged, and micro-front-end tried to do the equivalent of what microservices did. However, it does it for the front end. So it breaks down your front end application into, multiple applications that are then combined to form a sort of a composable UI, and to the end user, it appears to be one application and has like a seamless user experience. But under the covers, of course, it's broken down into multiple applications that are combined at runtime. So some of the benefits of micro-frontends, and these benefits are similar to the benefits that you would receive or that were claimed that you would get if you built microservices. So simplified development and maintenance. So of course, if you break something that's large down into smaller pieces, they can be much easier to develop. They're a lot more focused on solving a specific problem. And then they can be maintained and updated much more easily as well. They also can have improved collaboration, meaning that one of the problems when you have a large code base is if you have a lot of different developers working in that code base in parallel, sometimes, they can step on each other's toes, they can interfere with one another, and it causes a lot more challenges in terms of coordinating the work. Whereas if you break things down much more cleanly into independent parts, you can have independent teams that work on those different parts in parallel without affecting one another. So that's another huge benefit of the micro-front-end approach. Other benefits, so you've got the notion of increased agility as well. So meaning that each module can be deployed independently from one another. So that means that you don't have to try and coordinate one huge monolithic push to an environment in order to, deploy new software, patch it, what have you. So breaking things down into smaller parts allow those parts to be deployed independently, and that can expedite the release process, making it much more fast and more efficient, and also leading to quicker time to market in some scenarios. In addition to the fact that the applications have been broken down into smaller pieces, of course, you still have an app host, and that app host is responsible for some of the, the more global nature of bringing the various pieces together. But that application host can also be upgraded independently from the individual modules. So basically, by breaking things apart, you've got a lot more flexibility in terms of the way that you can service and deploy the application. And you've also got improved extensibility as well. So if you need to perhaps enhance the application with a new feature, if you've followed an architectural pattern where things are broken down into smaller pieces and done in a more dynamic way, then it's much easier to introduce a new feature, as you don't have to, integrate that small feature into this huge application, do regression testing on the entire application, and then deploy the entire application just to get one new feature. So the extensibility model can be a lot more efficient as well. Of course, there are drawbacks as well to micro-frontends. One of those drawbacks is that it is a bit more complex. So there is an increased complexity in building these types of applications. So, creating that architecture so that you can manage a micro-front-end system is a lot more complex than building a monolithic application, because you have to think about how to cleanly separate all of the different pieces. And then how are those pieces going to communicate with one another? And how are you going to integrate it all together so that it seems like it's one cohesive unit? So that introduces complexity. And it basically involves, more architecture up front to define these things, which can then reap rewards later. There's also some additional deployment overhead, much in the same way that microservices have some additional deployment overhead. Because on the back end, of course, if you're going to use maybe a containerized approach, and you have to orchestrate all the different containers, and you have to orchestrate the different deployments of the different back end microservices, you take on some additional overhead when you use a micro-front-end approach as well, because you have to keep track of all of the different pieces that make up the front end. And you have to make sure that you can deploy them independently from one another and integrate them. And often the infrastructure and the tooling that you're used to using doesn't naturally support some of the different flows that you're going to need to follow. And so because of that, there's some deployment overhead as well. And then there's some other topics around micro front ends, and I refer to this as dogma, meaning, things that smart people have sort of recommended as, part of what micro front ends should provide. But in these cases, they're not necessary. They're more subjective. So they're things that maybe some people believe are important, other people don't. And like anything that's dogma, you should not just blindly follow the rules that somebody else has established, right? You should kind of understand what the problem is that you're trying to solve, and then apply the different technology or approaches to solving the problem, right? Blindly following others and following sort of like the cult approach means that you don't really understand what you're trying to solve. And so I would always kind of recommend against that sort of dogma mentality. But I've got to mention these things, because if you're going to do further research into micro front ends, you're going to come across these things one way or the other. So one of them is isolated deployments. So much the same way that microservices had some dogma around it that basically prescribed that every microservice needs to run in its own process, needs to have its own database. Of course, those were like rules that you could follow. But the whole idea behind microservices was basically to be able to break things down into smaller pieces so that they were independent from one another. It didn't necessarily mean that you had to use a dedicated database for each. That's a deployment concern, right? That's a deployment decision that you can make. If you architect things in the right way, of course you can deploy it in that way, but you could also deploy it in other ways. You could combine some of the deployments together if you wanted to save on infrastructure and reduce the complexity. So that's why I call this dogma. There's the pros and cons, and so you shouldn't blindly just follow the rules. So isolated deployments, not necessarily like a must-have when you're building micro front ends. It can help you scale in certain scenarios, so it could be helpful in some scenarios, but it's not necessarily required. Similarly, technology agnosticism. So similar to the fact that microservices, allow you to use different types of technology on the back end. Some people believe that, a micro front end solution should also provide that kind of capability, so that, on the front end, maybe you can use many different frameworks, UI frameworks, like maybe like in the JavaScript community, maybe you want to use React, and you want to use Angular, and you want to use Vue, right? And so that was what some of the early solutions around micro front ends like single spawn, others were designed to accommodate. However, in the real world, you'll more often find that organizations are standardizing around a specific technology stack. And so they don't really care about technology agnosticism, and they're happy just using one consistent technology in the front end across all the different UIs that are created. So again, this is not a requirement in building micro front ends, is having this agnostic approach. More often, you're going to choose one specific UI technology and use that in all of your front end implementations. And I would also say that although I've seen in the JavaScript world some examples where technology agnosticism was achieved, it always comes at a cost. It always has hidden sort of challenges that you need to overcome. Plus the applications that you build. If you're trying to use multiple UI frameworks, you need to also consider the runtime performance impact, because you're going to be pulling in many different framework dependencies for each of those UI frameworks into the application, which you can only imagine how large and bloated the application becomes if you try to follow that approach. So that's why I said this is Dogma, not required. However, in some scenarios, you might think that this is useful. And in those specific cases, then you can, of course, explore it further. Another concept in Micro-Frontend is the notion of sort of atomic design. And so we all know that applications are actually made up of a lot of different parts. And if you look at this from a more scientific or biological level, things are in nature comprised of, at its basic level, atoms. Atoms then are organized together as molecules, and molecules are organized together as organisms. So if we think about technology and we think about like micro front ends and UI, you can think of sort of your primitive UI elements like a label or a button as being like your atoms, right? Those are your very basic building blocks of your UI. Those are often going to be combined together in more rich components. So components which use the primitives to solve a specific business problem. However, those components are still very focused in what they're trying to achieve. Very focused on specific use cases. The next level up would be modules. And modules, of course, could accommodate many different types of components, and they're designed to solve a broader sort of business use case. And it's at this level that you should be thinking about micro front ends. So when you're breaking up your application into smaller parts, you shouldn't break it down to like the element level. That's way too granular to consider as a micro front end. So typically, you've actually got to think about it at the module, like sort of mini application level. And of course, even the higher level beyond modules would be maybe pages in an application or specific UIs, and those UIs can be comprised of perhaps many different modules. So with this atomic design concept, trying to sort of demonstrate where you should be focusing your effort in terms of the granularity for micro front ends. So now we're going to talk a little bit about micro front ends with Blazor more specifically. Up until this point, we've been talking about the general concepts of micro front ends, which I hope was useful, but it sort of sets the stage for talking more about micro front ends in Blazor. A lot of the stuff I'm going to share are based on the lessons that were learned in developing Oqtane, which is an application framework that's an open source project that I developed using Blazor, and it also supports .NET MAUI, of course, through the Blazor hybrid concept. But I mean, a lot of the problems that I had to solve in modern .NET and Blazor were by implementing these features in Oqtane. So if you want to check out Oqtane, of course you can. It's on GitHub, and the main site for it is at www.oqtane.org. So the main considerations when you're building micro front ends in Blazor. So there's some high-level concepts that you got to keep in mind. There's some caveats around the development environment and approach. And then there's a number of different more specific things related to Blazor, which I wanted to cover as well, which will help you be successful in taking a micro front end approach with your applications. So first off, some very important concepts. So if you are more used to building traditional applications, and this might even be, using Blazor, that could be Blazor WebAssembly, could be Blazor Server, but more in the traditional way, using the standard Microsoft template that they provide for you, then essentially what you're building are monolithic applications. They might have, they might be SPA applications and have a discrete front end and back end, but they are not micro front end applications. They are a lot more static in nature. They're tightly coupled. They tend to be more sort of concrete in their implementation. They have a lot of dependencies. and those dependencies are sort of hardwired to one another. In a lot of cases, there's a lot of hard coding, and I know that developers don't like that word, but when I'm referring to hard coding here, I'm referring to like references to things that are embedded directly into components, like perhaps references to other components. That's still is hard coding at the end of the day. And applications built in this way tend to be more rigid and are less, um, just not as easy to extend. Whereas if you're thinking about a micro front-end application, it needs to be modular, meaning like everything needs to be thought of as broken down into discrete parts. It needs to be dynamic. So in a lot of cases, you're going to be actually dynamically creating objects and injecting those into the UI. That's dynamic. You're not going to include as many hard-coded static references to things in your UI. Things are more loosely coupled, meaning they're very independent from one another. They're developed independently. They're deployed independently. Usually, in order to achieve this, you need to have some abstractions, so some interfaces or other types of contracts that things can adhere to so that you can integrate things together. Of course, in a traditional application, you don't have to worry about those abstractions. You just bundle it all together, glue it all together, and it's all going to work. But you have to think about these things in a more cleanly abstracted way if you're building micro front ends. The code is developed in a more independent manner. The UI can be more metadata driven, meaning you would have configuration to describe how your UI is going to be laid out, as opposed to just including hard-coded references to things throughout your application. And it tends to be a lot more flexible. But these are these are concepts that most developers are aware of. They know what they mean, but in a lot of cases, they actually haven't had the opportunity to implement them in a practical way. And so as soon as you start going down this path, you realize that .NET can handle all of this stuff, but it's not simple in a lot of cases. It's not like it doesn't rely on a lot of the knowledge that you've acquired previously. Sometimes things don't work the way you would expect them to, and then you've got to solve those problems. One of the big challenges when it comes to micro front ends is around the development environment and basically the development approach. So tools like Visual Studio and Visual Studio Code are more catered, from a default perspective, around developing monolithic applications. They also take advantage of a lot of magic, I call it. So meaning that they do a lot of build and publish optimizations based on identifiers that they can find in the code. So when you build an application in the traditional way, you're including a lot of hard-coded references to things, right, in your startup, in your project files. And the tooling can pick up on those hard-coded references, and it can do some magic behind the scenes, things that you're not necessarily aware of. As soon as you start breaking things down into smaller pieces and using a loosely coupled approach, the tooling is not going to support you because it doesn't have those hard-coded references to follow anymore. Right? So if things are expected to be composed dynamically at runtime, that means you're out of the realm of the development tools at that point. And so they can't help do that magic that was being done in a traditional application. And so because of that, you really do, as a developer, need to understand what the magic is that those tools are doing. You need to understand how, when you include a reference to a NuGet package, what is actually happening there? And what is happening both at the time that you compile the application, but also when you publish the application. And you'll find out that NuGet's doing, Visual Studio or the tooling is doing a lot of extra things that you weren't aware of, right? It's copying assets out of the NuGet package to various locations. There's a global asset cache. There's all kinds of things that are happening behind the scenes that you are totally unaware of. However, when you're building an application in a micro front-end way, you need to manage that process manually yourself in some cases. So you need to understand how it all works, how everything fits together, and basically in order to manage the overall process. And so this is one of the big challenges that people have to overcome, because when they start building things as more discrete, independent applications, they naturally wonder why things don't work. And that's because, a lot of the dependencies and assets and things are not being copied to the appropriate locations because Visual Studio just can't do that, right? It just doesn't know. It doesn't have the information required to do it. So these are the complexities around building micro-frontend applications that you have to deal with. So when we build Blazor applications, of course, there's and even with micro-frontends, there's going to be sort of one Blazor application, which is the app host, which is responsible for bootstrapping the entire application, right? It's responsible for dealing with all the requests, doing all of the coordination, loading all of the UI components. So that's your app host. It's going to also be responsible for all of the cross-cutting responsibilities in your application. So things like authentication, authorization, logging, all of that cross-cutting stuff that you're used to putting in startup will still be there as part of your Blazor app host. It's also responsible for standardizing the UI. So if you want everything to look consistent and behave consistently in your application, then you're going to have to establish some standards at sort of the highest level. So you'll, basically, if you're going to use a specific flavor of CSS, maybe you're using Bootstrap or Tailwind or whatever, you establish that in the app host, make that available, make sure that all of the resources are loaded appropriately so that they're available, and then the micro-frontend components can use them. So this might also include things like shared component libraries. So if your application has a bunch of different UX scenarios, like maybe a file picker or specialized combo box or various things, you can have a shared component library that is part of the app host that all of your different micro-frontends can take advantage of. And that would also be the case for third-party UI component libraries. So maybe these are open source like Blazor or commercial like Telerik or Syncfusion or others, right? So those types of sort of global concepts that you want to use across your entire application can be defined in the app host. The app host can also be responsible for state management. And so often application has at least some global state, although you want to try to keep this to a minimum. But by providing at least some global state to the various micro-frontend components, you can create a more cohesive story and an easier sort of development model for people to follow. And also providing capabilities so that these different micro-frontends can communicate with one another using the various mechanisms that are available within Blazor. So all of these things would be things that the Blazor app host would be responsible for. And then, of course, in Blazor, you have a whole lot of different options when it comes to the different hosting models, meaning Blazor Server or Blazor WebAssembly. And you have different options when it comes to render modes as well. Of course, you can use interactive render modes or static render modes. And so usually the app host is going to define the different scenarios that the application is going to support. So fundamentally, when you're building micro-frontends with Blazor, we've already talked about sort of the atomic design principle and the level of granularity that you need to break things down to. But those mini applications that we're talking about would be built as Razor class libraries or sometimes called RCLs. But Razor class libraries have been around since Blazor was first introduced, because the whole idea behind Blazor was that you can have reusable code, right? You can build components that are reusable. And the way you do that in Blazor is with Razor class libraries. So in a traditional Blazor application, often you would include all of your UI components in the same project, or at least in the same solution. Whereas in a micro-frontend Blazor application, each of these modules or micro-frontends will be developed and deployed independently, right? So they'll be their own distinct solution with perhaps, at least a client project. They may have other projects that are part of them as well. And that all is, makes up your Razor class library. Your Razor class libraries are usually packaged independently as well, and they're usually packaged as NuGet artifacts. So in the standard way that anything is packaged as part of .NET. The next thing you have to tackle when it comes to micro front ends is assembly loading. So, and I've broken down assembly loading into the two different sort of workloads that you need to be thinking about. So there's the server workload, and then there's, of course, the client workload as well if you're using WebAssembly or Blazor Hybrid. But assembly loading is important. In a traditional Blazor server application, all of the dependencies of the application are statically defined as references within the application. And so because of that, when you run the application, it knows which assemblies it needs to load by default. In a micro front end model, the Blazor server application doesn't know, right? Because everything's loosely coupled. You don't have hard-coded references to things in the app host. So the app host needs to take responsibility for discovering what the different assemblies are that are part of the application and then loading those dependencies. And so the way that you would do that is, of course, you would use some of the built-in .NET capability. So system.runtime.loader has an assembly load context, which is really helpful for this capability. Your application can figure out whatever scheme it wants to use to identify the different assemblies that are part of your overall application. And then it can use assembly load context to load them dynamically. One thing with assembly load context is it has a resolving event handler, which is quite handy, and you should probably implement it, because if you have assemblies that are being loaded, sometimes those assemblies have their own dependencies. And the resolving event handler allows you then to hook when there's a missing dependency, and then you can write your own code to tell the application where to find that dependency so that it can be loaded as well. So again, this is so some of the magic that you're used to just happening by default in a traditional Blazor application, you have to take responsible for if you're going to use the micro front end approach. On the client side, if you're using, WebAssembly or Blazor Hybrid, there's assemblies that need to be downloaded to the client, right? And that could be the client browser, or it could be a client device. In a traditional Blazor client application, again, all of the references are statically defined. So by default, Blazor knows how, exactly which assemblies need to be downloaded. In a micro front end application, again, with loose coupling, and things are not hard-coded anymore, the app host, so on the client side, needs to take responsibility for downloading the assemblies from the server, right? So it needs to be able to make a call to the server and say, hey, get me the assemblies that need to be downloaded to the client. And you can use, the standard HTTP client to do that. There's a get byte array async, which allows you to download essentially, binary files, assemblies from the server. The thing that you have to keep in mind, though, is just like we were talking about the event in the previous one for resolving dependencies of assemblies, on the client side, you need to come up with some scheme, right, to be able to identify the dependencies that might exist for assemblies. Because if you're downloading just one assembly, you might not be getting all of its dependencies. And so in the cases where an assembly has other dependencies, you need to be able to download those as well. And then, of course, on the client, you would still use the same dynamic mechanisms to load the assemblies into the app domain that's available on the client side or on the device. And so this is only, of course, pertinent if you're building a client Blazor application. You don't have to worry about this if you're strictly building a Blazor server application. Application startup is another thing that you have to consider. So in a traditional Blazor application, all of your services are usually statically defined, in your startup class, right? It's you're basically registering all of the different services as part of the app container as part of startup. And so again, you're hard coding all of those references in startup. In a micro front end application where things are loosely coupled, the app host is going to need to be able to dynamically discover the services that exist within your assemblies and then register those services. So you're going to have to use a more dynamic approach for this, right? So it's going to have to basically do some type of inspection on the assemblies that are part of your application, determine if they contain services, and then dynamically register those services into the app container. And all of this needs to happen during startup. Because I've included a note here, meaning like if you're using the default dependency injection container that is part of .NET, services can only be registered at startup. So what this means is that if you are deploying a new micro-frontend, and that micro-frontend maybe contains some type of a service for calling a backend, the only way that you're going to be able to register that service is by restarting that front-end application, right? Because this is a limitation of the default DI container within .NET. It's only going to be able to do startup, or basically service registration logic at startup. There are other DI containers that exist in the .NET community, like some of them are open source. And some of them have more dynamic capabilities so that you could actually add new services dynamically without restarting your application. But by default, if you're using the defaults as part of .NET, you're going to need to restart, the application in order for those services to be registered. Routing is another concept. Like the app host is responsible for routing. In a traditional Blazor application, you use the app page directive, and that identifies those components that are designated to be pages as part of your application. And then it normally, if you're building like a monolithic Blazor application, you don't need to worry about this concept of additional assemblies. But if you've broken down your application into multiple assemblies that might have front-end components to them, then you are more familiar with this notion that you can declare your assemblies through the additional assemblies property. In a micro-frontend application, it's absolutely necessary to basically tell Blazor about the pages that are part of your application. And this will be done in a more dynamic way than what it is done normally, because like in a traditional Blazor application, even if you're using the additional assemblies property, you're still hard coding, in that collection, all of the different assemblies that are part of your application. Whereas in a more loosely coupled way, you need to write code so that it discovers the assemblies at runtime and populates the additional assemblies in that way. So maybe using reflection. Or another approach is that you can actually abstract your routes to a completely different location, like maybe a database or the file system. And in that way, then you can have a more dynamic way of dealing with routes in your application. And in fact, this is the way that things are done in Oqtane, and I'll explain that in a minute. Component rendering. So in the traditional Blazor application, you include references to components in pages or within other components, and those are all very, statically defined. Whereas, in a micro-frontend Blazor application, you may want to use configuration to basically identify the different components that should be rendered in different scenarios. And then you can use the dynamic capabilities of Blazor to actually render the components dynamically at runtime based on metadata. And there is a component that's available as part of Blazor called Dynamic Component, which makes it very easy to dynamically load a component based on its type name. And so you can use this to do a lot of dynamic injection of components into the UI. Of course, this metadata that I'm talking about would be something that you would store somewhere else, maybe in a database or the file system, or somewhere. Maybe even the metadata is stored within other components. But it's a way that it can determine dynamically the different types that need to be loaded as part of your UI, and then it would use the dynamic component mechanism to load them. And then deployment. So in a traditional Blazor application, you can use the standard sort of publishing mechanism that's part of, .NET Publish or through Visual Studio or VS Code to automatically, build a deployment, or like, basically build the set of assets that are part of a deployment. And the reason why this works in a traditional Blazor application is because, again, all the dependencies are statically declared, right? They're hard coded throughout your application. And so because of that, Visual Studio can, figure out where all the assets are, and it can build your deployable image based on all of the hints that it has. This is not the case in a Micro-Frontend Blazor application because everything is loosely coupled. So you need to take responsibility for identifying all of the different parts that are part of your application, so that they are all part of your, published image, and then you can, publish that. The other thing, of course, with Micro-Frontends is you really don't need to publish the entire application with all of the different Micro-Frontends every time. Like, the whole point of using Micro-Frontends is that you can do more granular deployments, right? So things are broken down into smaller pieces, and those smaller pieces can be independently deployed without having to push out the entire, application every time. So the challenge here is that you probably have to develop some customized deployment process, because the standard tooling that you're used to using, like just, through Visual Studio, creating a published profile and publishing the application, isn't going to pick up all of the dependencies of your application because it doesn't know about them, because they are loosely coupled, right? They're not tightly coupled. So it doesn't even know about them. So you'll have to figure out how to allow the deployment process to take place. And so for a demonstration, I'm going to use Oqtane as the example, just because it has a lot of these very complex concepts that are built into it already. So I'm going to show you, essentially, this is the Oqtane website. And if you want to find out more about Oqtane, you can. It's obviously an open source project that's been around for 7 or 8 years now, and it has a lot of capabilities that are part of it. And one of those capabilities is supporting the notion of micro-frontends. I have a site, just a test site. This is actually a free .NET site that I was able to spin up using monsterasp.net. So they're a hosting provider that actually provides free .NET hosting. I just had to go there, provide an email address, and basically I got a free account that I was able then to deploy the Oqtane solution to. This solution is, .NET Core. It's running on .NET 9. And for the back end of this one, I just used a SQLite database because Oqtane supports SQLite, SQL Server, MySQL, and Postgres. But for simplicity, I just use SQLite for this example. This is a default installation, and then in that default installation, I've installed sort of one custom theme to give it sort of a nice look and feel for the home page of this application. And it's got like a lot of kind of, rich kind of content that it shows on the home page. But yeah, so it's what you would consider maybe a modern website to look like. But the point here is to not focus on like building websites or web applications. This is more about micro-frontends. So on this site, what if I wanted to have a additional capability on this site? Maybe I want to have a blog on this site. If this was a traditional Blazor application, we can imagine that in order to create a blog, we'd have to add basically the blog functionality to our Blazor application. We would have to modify our navigation menu so that the user has a way to navigate to that blog page. We would have to basically create a whole new deployment of our application and push that entire application, which includes now the new blog module, to our environment. And then, of course, then we'd have a blog module on our site. That would be the traditional way of doing it. When you're using a micro-front-end approach, the blog module can be developed as its own independent project. And I don't need to care about all of the rest of the Oqtane framework and the content of these pages and basically all of the rest of this. I only need to focus on the blog module. And I would develop that in Visual Studio. So here's an example of the actual Oqtane blog module. So in order to create a micro front end, you would create it using a Razor class library. So this the client project that's part of this solution is using the Microsoft.NET SDK.Razor, which is creating a Razor class library. This particular module has both a front end, which has all of the different Razor components as part of it. It also has a back end. So in this case, there's a separate project that produces its own assembly for managing the back end concerns of this blog module. So it has its set of API controllers. It's got its repositories. There's a shared project net as well, which has the different models that are part of the blog implementation. It also has a package folder. This is obviously not something that you would normally have seen previously, but in Oqtane, by default, we kind of have this standard that we have a package folder. And the package folder includes some additional concepts in it so that, for example, when I'm developing in my development environment and I do a build on this blog module, it has a post-build step, which executes this debug.command file, and it copies all of the assemblies and the debug symbols and any static assets to my Oqtane server environment, so that it places basically I'm taking responsibility for copying the assets for this project when it's built to the appropriate location, so that when the application runs, it can discover this micro front end. So this is what I've been talking about previously in the slides. You have to take responsibility in some ways for doing things that you didn't have to think about previously. If you were building a traditional application, you wouldn't have to do any post-build step or copy things in a particular location. That's because everything lives within one solution, and Visual Studio can figure all that out for you. So because this is a distinctly separate project that lives outside of my Oqtane framework, I need to manually figure out a way to copy things to the appropriate locations. And so that's what this package project is for. If I compile this application in release mode, it will execute this release command file, which essentially just does a pack command using this new spec file. And it basically packages up all of the assets that are part of this micro front end module and we'll package it into a NuGet package. And so I actually have that NuGet package that it created here, Oqtane.blogs version 6.1.2. So it created a NuGet package when I compiled this in release mode. And so what I can do now that I have this NuGet package is, I can do a deployment. Of course, I could automate this if I wanted to using like a CI/CD approach. But for simplicity for this demo, what I'm going to do is I found the folder where that package is located on my local system, and I had logged in using FTP to that remote Oqtane installation, and I'm going to just drop this blog package into this packages folder on the remote site. And so it moves that package over, and so there it is now on the remote site. I'm going to go back to that remote site. And what I can do in Oqtane is, because this is because it doesn't have an SSL certificate in this free site. I can go into my system info because this is what I explained previously. So if we go back for a moment, I guess, to the blog project, and we look in our services, we have a number of different services that are defined in here. For example, we have a blog service. And these services are actually going to be calling back-end API methods using HTTP client. But these are services, and so they're part of my front-end project. And so the only way for .NET to be able to register these services on startup is for me to restart the application. So when I go back to the website where this is all running, I can restart the application here. This is just Oqtane provides the ability to interactively restart the application. So as part of the restart mechanism, it recognized that there was a NuGet package in that packages folder. It automatically extracted all of the assets from that NuGet package into the appropriate locations on my target environment. During startup, it recognized that there were assemblies that Oqtane cares about and interrogated those assemblies to find the services that were part of them. It registered those services as part of startup. And now, let's say we want to create a new page in this site. So I'm going to add a new page. I'm going to call it the blog page. I am going to say that all users can view this blog. I'm going to put it after the home link, and that's it. So that'll create me my new page. So I have a blog page now. In my menu, I have the blog page. And now if I look into my module list, there's my blog that was installed simply by dropping that NuGet package into my environment. And I can add that blog to the page. No blogs have been published yet. I can add a blog, with the title, summary, description. I can say it's published as of today. And that didn't work. Not sure why. Oh, maybe because it's using SQLite. Anyways, yeah. So the idea there, though, is that I published. So if we go back and we refresh this folder, we can also see I don't have a refresh option. Oh, we'll go there. Interesting. So anyways, the idea was that the blog module was deployed to the environment, and that sort of demonstrates how you can do a selective sort of deployment to the so I didn't have to basically do a complete application deployment. I was able to deploy a discrete micro front end to the application, restart it, and get new functionality in the application very simply without having to basically add functionality to the overall application and do a complete deployment of that application. And that's one of the biggest benefits of micro front end architecture.